Good afternoon, everyone. Uh, is everything clear? Is my voice audible? Screen visible? Just give me a thumbs up very quickly so that we can start our session. Okay, I think it's clear. Okay, so today we are going to discuss the test that is held in the first shift of from 10 to 11, 10 to 1, I think. So just tell me, how was your test? How was your full syllabus test? We will discuss few questions. Okay, and we'll try to solve a maximum number of questions. Okay, so first question is on your screen. The question says, raindrops are falling vertically downward. Let's draw this. What is it saying? It is saying that raindrops are falling vertically downward. This is velocity of rain with respect to ground. Again, they say a man is moving with a speed of 10 kilometers per hour horizontally along x direction, and a man is moving in the horizontal direction like this. This is velocity of man with respect to ground, and this velocity is given as 10 kilometers per hour. You can see that. After that, he feels that raindrops are hitting him at an angle of 30 degrees from the vertical. Like the situation, you can see that if a person is walking this way, then he may feel that rain is coming in this direction. That's what you can actually observe by your while moving in the rain. Whenever you go out in rain, then you can observe that rain, which is actually vertically downward. When you start walking or start running or you start biking, then it comes on your face. So it bends. And his question says it comes at an angle 30 degrees from the vertical. That means rain is appearing something like this. So for man, this is velocity of rain with respect to man, which makes an angle 30 degrees with the vertical. So this angle will also be 30. What you need to calculate? Calculate the speed of raindrop with respect to the man. That means you need to calculate VRM. So from relative motion, what you know, velocity of rain with respect to man is velocity of rain with respect to ground minus velocity of man with respect to ground. You can see that this is the relation of relative velocity. Now, again, if I say, if I take components in x direction, if I take all the components in x direction, then what it will be? Just wait for a minute. Okay, after that question, I will check that if there is any problem with the Zoom meeting. Anyways, in x direction, if I say, that will be, we will take the component of VRM in x direction. That will be VRM sine 30 negative x direction is equals to VRG is along the y-axis. So its x component is 0 minus VMG is what? 10. So minus and minus will cancel out. It will become VRM by sine 30 is 1 by 2 equals to 10. So VRM is equals to 20 kilometer per hour. That's what is the answer. So give me 1 minute. I will check. Okay, is everything clear to you now? Okay, is everything clear? First question we have already done. Am I audible to you? Very good. Okay, so let's move further for the second question. Okay, second question says, what is the dimensional formula for K? This is again a very simple question. It is given as K is equals to d4x over dt4. Here you can write that dimension of x is length divided by dimension of time is t, which has a power of 4, that is L t raised to the power minus 4. Nothing to do with that. It's a very simple question. So we will not take a lot of time. We will take invest our time in another question like this. Okay. How many of you have solved this question in the examination today? Question says a body covers 26, 28, 30 and 32 meters in 10th, 11th, 12th and 13th second respectively. Okay, so whenever the question is for, or you can say 10th second, 11th second, what is it? This is the nth second. And for nth second, formula of distance is S, or distance or displacement in the nth second is U plus half A 2t minus 1 for nth second. So here you can say that if I talk about for 10th second, 10th second distance covered is what? 26 meter is equal to U, we don't know, plus half A. T is what? 10. So if you multiply 2, it will be 20 minus 1, that is 19. So you can form a equation from here. Again for 11th second, for 11th second, distance cover, I am putting this value in equation, this one. Distance traveled is 28 meter is equals to again U plus half A. 2t minus 1, if you do, it will be 22 minus 1, that is 21. So there are two equations. This is equation 1, this is equation 2. You can solve these equations and you will get U and A. After solving, you will get U and A. And according to that, you will get your answer. According to that, you will get your answer. If you want me to solve it, then I will solve these equations. These are linear equations and can easily be solved. If you want me to solve, then I will solve it. Otherwise, I will move further. Just give me an indication what you want. Be quick in response. I'm waiting. Otherwise, I will move further on the next question. Can you solve these equations to get U and A? Okay, Logesh is saying, please solve. Okay. Then we will solve it. Okay, if you want to solve it, what you can do, we can take the LCM here. What we can do, or we can directly solve it here on this side. If I say, first equation is 26 is equals to U plus 19A by 2. If you take the LCM, it will become 52 is equals to 2U plus 19A. Clear? This is 2U, not 24. Now, if similarly, if you solve this second equation, it will become 56 is equals to 2U plus 21a. And if I solve this, minus, 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 what you will get, these two terms will be cancelled out. It will be minus 4 is equals to, can you see that it will be minus 2a? So a is equals to 2 meter per second square. That means body has some acceleration of 2 meter per second square. If you put this value in either of 3 and 4, you will get u. So I am putting this value in equation number 3. What I will get, 52 is equals to 2u, u is the initial velocity, plus 19 into acceleration is 2, that is 38. What you will get, 2u is equals to 52 minus 38 is 14. U is equals to 7 meter per second. That means particle has some initial velocity and moving with constant acceleration. So which option is correct out of these? With an initial velocity and moves with uniform acceleration. So option C is correct. Is it clear now? Logesh. Moving further on the next question. Okay, this is again a very good question. What it says, let's suppose this is, we are drawing the FBD. Okay, is this visible? Okay. According to the question, the block has a force of 10 Newton. This 10 Newton is acting like that. Just imagine when you compress the block on the wall, then wall will react and it will exert a reaction force N. This is normal reaction. Where the weight of the block, that is W, will act downward. Mg, that is weight, will act downward direction. And if you can see this block, this block has a tendency to slip down. If this force of 10 Newton is removed, then this block will slip down. So friction will act in the upward direction. Friction will act in the upward direction. So this is the direction of friction. Friction. Small f is friction. Now, in the x direction, you can see the block is not moving. The block is actually not moving according to the question. If block is not moving, that means these all forces are in equilibrium. So in x direction, normal reaction is equal to 10. Can you identify this, or should I explain or elaborate it more? That this normal reaction is acting in the left direction. This 10 Newton force is acting in the right direction. The sum of both should be 0. Only in that case, it is not moving. So if the sum of these two forces is 0, that means N should be equals to 10 Newton. One thing is clear. Now, what is the frictional force? We know that frictional force is nothing but mu into N. You know that. Now, mu is what? 0.2. And normal reaction is what? 10. So frictional force is 2 Newton. Again, next thing. Now, if we know the frictional force, you can see in y direction, how many forces are there? You can see there are two forces, F and W. One is upward, one is downward, but the sum of both is 0. Why 0? Because block is not moving. So what you can write, F is equals to W. So W is equals to F, and F is what? 2 Newton. So what is the weight of the body? Weight of the body or weight of the block is nothing but 2 Newton. This is option number C. Moving further. Very good, Bina. Next question. Question says a string of length 10 centimeter breaks if its tension exceeds by 10 Newton. That means maximum tension in this string can be 10 Newton only. Now again they are saying a stone of mass 250 gram tied to this string is rotated in a horizontal circuit. Now mark it. In the previous test, there was a question on vertical circle on the same track. Now there is a question of horizontal circle. Let's draw it. This is a particle rotating in horizontal circle like this. This is the center point. This is the mass, which is m, and tied to a string like that. Now question says, when it revolves, the tension in this string will be T. And when it moves, then tension is, or the centripetal force is provided by this tension. So tension is equals to mv square by r. Mv square by r. So if the tension is maximum, then velocity will also be maximum. So maximum tension is what? 10 Newton is equals to mass of the block is 250 gram. That is 0.25 kg. Velocity we don't know. Radius is what? 10 centimeter. 10 centimeter means 0.1. You can solve it. So V square is equals to 100 by 25, that is 4. So what it will become? V is equals to 2 meter per second. When velocity is 2 meter per second, what will be the omega? You know the relation V is equals to R omega. So omega is equals to V by R. Velocity of V is 2. R is what? 0.1. That is 20 radian per second. The question is again very simple. The question was of horizontal circle. Horizontal circle means that centripetal force will be provided by the tension. So this is the condition that we have used. They are asking us the maximum angular velocity. Angular velocity is omega, and it will be maximum when velocity is maximum. So that's what we have done. Take a screenshot if you can. Moving further. Okay, the next question. Read the question. Question says, a solid sphere starts rolling. So first thing that I have noticed in my mind is rolling down on an inclined plane of inclination theta. The speed of its center when it has covered a distance L. Okay, so let's draw it. So there is an inclined plane. You know the inclined plane. This is the inclined plane of inclination theta. And there is a block, sorry, there is a solid sphere. This is a solid sphere, let's suppose. This is a solid sphere. It starts rolling down the inclined plane. The speed of its center when it has covered a distance L. So let's suppose this total distance is L. This total distance is L. So they are asking us speed of the center of mass. This is the center. Speed of the center when it has reached down the incline. Something like that. Okay. So now let's discuss about rolling motion first. I will delete it. Let's suppose this is a body which is rolling. Like that. So whenever a body is rolling, there maybe you can consider 3 points, or you can consider any point, but 3 points are most important. This is point of contact, this is center, and this is topmost point. Clear? Then velocity of center point is VCM is equals to R omega. This is what you should remember from rolling motion. Whenever there is a pure rolling, then velocity of center of mass is nothing but R omega. And velocity of contact point is 0. and velocity of topmost point is 2 times of r omega. This is what we should know before starting the question. Okay. Now let's solve it. Everything is clear now? Okay. So while solving the question, let's start. Okay. Now what I can say, velocity of center of mass is equals to r omega. Clear? This is equation number first. Now, using work energy theorem, if you can use work energy theorem, what it says that work done is equals to change in kinetic energy. From this point, it has started rolling. Yani ki initial, this is the initial point, and this is the final point. So work done. Who is doing the work on this on this solid sphere? Gravity is doing the work. So work done by gravity. M, let M is the mass of the solid sphere. G, and what is the height it has covered? It has covered this height h. From this point to this point, it has covered a distance L, but a height of h. And this h is nothing but in this triangle, if you can see, h is the perpendicular, L is the hypotenuse. So perpendicular is nothing but hypotenuse into sine theta. H is equals to L sine theta. So what is work done? Mg L sine theta is equals to change in kinetic energy means final kinetic energy minus initial kinetic energy. If I talk about final point is this one. At this point, the sphere will have two velocities. One is transitional motion or translational motion, another is rotational motion. So due to translational motion, it will have a velocity half m v square. And due to rotational motion, it will have a velocity half I omega s. Minus initial kinetic energy is 0. Now, you can place the values here. If I place few values, that is mg L sine theta is equals to half m v square. V is what? Velocity of center square. Velocity of center of mass square plus half moment of inertia of the solid sphere is 2 by 5 m r square, that is omega square. Do you know this thing now? That what is moment of inertia of a solid sphere, that is 2 by 5 m r square. Now if I move further, what you can see, m can be cancelled throughout. So it will be g L sine theta is equals to. Can you see that from equation 1, r omega is VCM. So r square omega square is VCM square. This 2 and 2 will also cancel. That is VCM square by 2 plus r square omega square is again VCM square by 5. Now just there is a simplification or there is a simple calculation. You can solve it. That is GL sine theta is equals to, you can take the LCM as 10. That will be 5 and 2, 7 VCM square. So what is the value of VCM? Is equals to 10 by 7 GL sine theta under root. This is your answer. Ask me anything you want to ask. Otherwise, I will move further. In which step you are facing some difficulty? One step, this is the condition of rolling motion, that is VCM is equals to r omega. In next step, what we did, we applied work energy theorem. And for work energy theorem, work is equals to change in kinetic energy. We have calculated work done and calculated kinetic energy, change in kinetic energy. Solve it. Okay, moving further. This is again a similar question. A ball is dropped from a height h on a floor of coefficient of restitution e. This is given. The total distance covered by the ball before second hit. I think this type of question is already done in the first test. How many of you remember the relation? I don't know. But this type of question is already done. Let's suppose this is a ball which is dropped from a height h according to the question. This is the question part. It is dropped from a height h. Now what will happen? It will come down the surface and strike the surface. It will now see everything. It will bounce from the surface again like this and will go up to some height. Let's suppose this height is this one. And again fall this one. This is the first hit and this is the second hit. So what they are asking, let's suppose after the first hit, it has raised by a height h1. Then what is the total distance covered by it? Now, what is the total distance? You can see that total distance before the second hit started from here. यहाँ से start हुई और end यहाँ पर हो रही है. It's ending here. So total distance, you can see it has covered a distance h, then h1 in the upward direction and then again h1 in the downward direction. So total distance is h plus h1 plus h1, that is h plus 2h1. This is the total distance. Now what we need to do, we need to calculate h1. And for that the relation was hn is equals to e raised to the power 2n h naught. This was the relation that I have discussed earlier in that class. So for first hit, h1 is equals to e raised to the power 2. H naught is the initial height, that is h. So h1 is e square h. You can place this value in this equation 1. So total distance will become h plus 2. H1 is what? E square h. You can take h common, 1 plus 2 e square. So which option is correct? H 1 plus 2 e square, that is option number D is correct. Nobody is responding. I think everyone is blank. What you should remember, this is the second time we are practicing this type of question. Is it clear? Should I move ahead? Very good. Again, this is very important question. Easiest question, but very important. These questions will increase your rank and will decrease your solving time. Question says if gravitational potential in a region is given by V is equals to 4x square, then gravitational field. So they are asking you the gravitational field that is denoted by E. So let's suppose first thing is the relation between potential and field. You should remember what is the relation. This is not the part of the question. I'm explaining it. The relation between potential and field is dV is equals to minus E dot dr. This relation you should remember. This is used a lot of time. Now, from this relation, we can modify our result that is required to solve this question. Potential is along the x region. 4x square, that means it is a function of x only, not y and not z. So whenever you want to calculate the field, remember this formula, field in the x direction is equals to negative of partial differentiation of potential with respect to x. This is the field in the x direction. Now field in the y direction will be partial differentiation of v with respect to y. Now what is the field in the z direction? You can easily write partial differentiation of potential in with respect to z. This is how you can easily calculate field whenever potential is given. Now potential is a function of x only. So which component of field is required here? Is x component of field is required only. So what you can say, that field in the x direction is equals to negative of partial differentiation of v. V is what? 4x square. And if you differentiate 4x square, what will be the differentiation? You will say 4x square will be, minus is already there. Differentiation of 4x square will be 8x. So field in the x direction is minus 8x. So minus sign indicates the direction. That is negative x-axis. So one thing is clear, 8x is the field in which direction negative x-axis. So option B is correct. Now, how the question may change? It may look like that potential is equals to 4x square plus 2y. Then calculate field. Now, potential is a function of x and y as well. So, which component of field you should calculate? You should calculate x and y in this question. If potential was given like that. So, I think everything is clear. This is a simple differentiation thing. Should I move further? Okay. So, there are a lot of questions. Let's be quick. After this question, we will move towards the class 12 questions. No? Okay, a constant torque of 31.4 Newton meter. That means torque is given 31.4. I'm not writing the unit, you can write it. If angular acceleration, that is alpha, is equals to 4 pi, what is the moment of inertia? This is not the question that is to be solved by me. Tau is equals to I alpha. So I is equals to tau by alpha. Put the value and you will get the answer. No need to solve it by me. I think it is clear. I is equals to, this relation is, you know this relation, na? Tau is equals to I alpha. Okay, you can do that. I'm moving further. You can get the answer. Say yes at least. Okay. So there are a lot of questions now of 11th. Okay, okay, okay. Okay, so let's do some 11th class question more. Okay. The question says, uh, a metal block experiencing an atmospheric pressure. That means some pressure is here. When the same block is placed in a vacuum chamber, the fractional change in its volume will be. So they are asking about the fractional change and bulk modulus is given. Bulk modulus is given. So what is bulk modulus? B is equals to. Nobody remembers now. Anyone who knows the bulk modulus? I think B is equals to what? Any modulus. whether it's young modulus, bulk modulus, or shear modulus, whatever it is always equals to stress over strain. It is always equals to stress over strain. Whenever we talk about bulk modulus, the bulk modulus is a volumetric stress over volumetric strain. So what is volumetric stress? You know that volumetric stress is equals to pressure, and strain is equals to change in volume divided by volume. This is B is bulk modulus is equals to generally the bulk modulus or any modulus is equals to stress over strain. Stress over strain. Clear? Now we are interested in delta P by V. So delta V by V is the fractional change in volume is equals to P by V. Now you can again put the values of P and V and you will get your answer. P is given as 10 raised to the power 5. V is given as on your screen, that is B. That is B. So everything is given, you can solve it. Moving further. Again, this is an important question. A new scale of temperature called W scale. The freezing point and the boiling points are 39 and 239. Okay, now listen to me. For any new scale or for any scale, one thing is common. First of all, identify the whenever there is a scale. Let's suppose you have a meter scale through which you put straight lines or you measure something. That scale has a minimum value of 0 and a maximum value of something 15 centimeter, I think 30 centimeter, whatever it is. You have that scale now. So every scale has the lowest value and the maximum value. One thing is clear. So can you see that the freezing point is the lowest point. Freezing point is the lowest point and boiling point is the highest point. Clear? So how we can write it for any scale? For any scale, one standard formula is there. Any scale, any temperature scale I am writing about. Clear? Any temperature scale, what is the golden formula? Let's suppose I am talking about this W scale. This W scale. Any reading on the scale minus the lowest point. The lowest point is what? Freezing point. Divided by highest point, that is boiling point, minus freezing point, is equal to a constant. This is the standard relation. That for any scale, let's suppose this is the W scale. So any reading on W scale and is constant means if I talk about, they are asking me the in Celsius scale. So for Celsius scale, what you can write? T minus freezing point divided by boiling point minus freezing point. Now put the values. After this question, everything will be clear. Okay. So W is being asked minus. In W scale, what is the freezing point? They are saying freezing point is 39 degree divided by boiling point is 239 minus 39 is equals to. In Celsius scale, they are giving a temperature of 39 degrees Celsius. So 39 minus freezing point in Celsius scale is 0 degrees Celsius, water freezes. Boiling point is 100 minus freezing point is 0. You can solve this equation, and if I try to solve it, it will become W minus 39 divided by 200 is equals to 39 by 100. This will get cancelled to W is equals to 78 plus 39. You can add 9 and 8, 7, 11. So W is equals to 170. What you got from this relation should be remembered. Somebody likes it to write as freezing point and boiling point. Somebody may write it as lower point and higher point. That's a different thing. Moving further, a capillary tube is taken. Is the Celsius constant for any scale? Okay, no. Any reading in Celsius will change in another reading. For example, if Celsius is, for example, I'm talking about, let's suppose 30 degrees Celsius. It will have different value in Fahrenheit scale, different value in Kelvin scale, and different value in any other scale that you can derive. So it's not constant. But this ratio term is constant that I am writing. This whole ratio term is constant for any scale. Not the Celsius value is constant, but this whole term is constant for any scale. If you write it for any scale, it will be a constant. Not the exact Celsius value is constant. Okay. Next question. Very good. A capillary tube is taken from the earth to the surface of the moon. Okay, this question is again from fluid, that is from class 11. After this question, I will take some class 12 question. This is the last question for class 11, whether it is last or not. Question says a capillary tube to the moon. The rise of the liquid column on the moon is acceleration due to gravity is something, something. So rise of the liquid column in capillary tube. So whenever we talk about capillary tube, the rise, do you know the capillary tube now? Like this in a container, if I put some liquid and put a capillary tube in it, then two things might happen. The liquid in this may rise or may fall. So this rise is denoted as rise in the capillary tube. This rise is denoted by H, and this H is given by 2t cos theta divided by R rho G. Each of the term has basic fundamental meanings, like T is what surface tension, theta is what angle of contact, R is the radius of capillary tube, rho is the density of the liquid, and G is the acceleration due to gravity. Now, the liquid will remain same, everything will remain same, capillary tube will remain same. So everything is constant except R. Sorry, except G. G is changing and everything else is constant. So you can write that H is reciprocal to G. So that's very clear. So H2 by H1 will be equal to G1 by G2. Now H2 by H1 is equals to G1 is G, that is on the earth. On the moon, it is G by 6. Clear? Clear now? So H2, so what is the, if action gravity is the rise of the liquid column on moon. So H2 is equals to, G will cancel out 6. So H2 is equals to 6 times of H1. 6 times of H1. Which option is correct? You can see. Which option is correct? 6 times of H1. 6 times of H1. This option is correct. Moving further. For class 12th, if I move about, this is class 12th question of modern physics. What they are talking about? They are talking about in the third orbit of hydrogen atom. De Broglie wavelength of electron is lambda. So one thing is de Broglie wavelength. So whenever someone is talking about de Broglie wavelength, what is de Broglie wavelength? Lambda is equal to H by mv. This is what de Broglie wavelength. Is it clear? This is the fundamental formula of de Broglie wavelength. Remember this. This is de Broglie wavelength. Now again, what you know from Bohr quantization rule, we know that MVR is equals to NH upon 2 pi. Do you know that? MVR is equals to NH upon 2 pi. This is Bohr quantization rule or Bohr postulate. This is Bohr postulate. Now, from this, we can calculate the value of MV is equals to NH over 2 pi R. What is H? Planck constant. R is the radius. So NV is NH upon 2 pi R, and we can place this value in equation 1. So lambda is equals to H upon MV is NH upon 2 pi R. So H will cancel. What will lambda be? Lambda is equals to 2 pi R divided by N. This is the golden formula that is to be remembered whenever they are talking about de Broglie wavelength of a revolving electron. Whatever may be the situation, whenever they are talking about de Broglie wavelength of revolving electron, you should use this relation. Lambda is equals to 2 pi R by N. Clear? Here N is the orbit. In which orbit they are revolving? N is the number of orbit, that is third orbit in the question. So we can place the value. Lambda is equals to 2 pi R by 3. They are asking the radius. So R will be 3 lambda by 2 pi. I have solved this every part to get this relation. But for you, it is necessary to remember this relation. Then you will solve this question within a second. So R is equals to 3 lambda by 2 pi. Which option is correct? That is again option number C is correct. Moving further. This is again from class 11th, I think. Okay. Let's solve one more question of class 12th after this. The amplitude of a SHM reduces to 1/3 in first 20 seconds. Then in first 40 seconds, its amplitude becomes. Okay. SHM, you know that SHM. If I talk about SHM, you draw it like that. SHM. But here the thing is different. They are saying that amplitude is decreasing. And whenever amplitude is decreasing, it means they are talking about some damped oscillations, which can be drawn as like this. So they are talking about damped oscillation. Okay. For damped oscillations, what is the relation that you know? You should know that amplitude at any given instant A is equals to original amplitude into e raised to the power minus lambda t. This is the relation where lambda is a constant. This is the relation for amplitude in damped oscillation. Now, what you know that at time 20 seconds, this is 20 seconds. Let's suppose this is time t, and they are asking for 40 seconds, and this time will be 2t. If I take t is equals to 20 seconds, then 2t will be 40 seconds. So I will put the values for time t. What are the saying? The amplitude SHM reduces to 1/3. 1/3 means A naught by 3 is equals to A naught e raised to the power minus lambda t. Amplitude becomes 1/3. From here you can get e raised to the power minus lambda t is equals to 1 by 3. This is equation number 1. Now again for time 2t, for time 2t. 2t means what time? 40 seconds. You can again write A is equals to A naught e raised to the power minus lambda into time is 2t. Can you see that A is equals to A naught e raised to the power minus lambda t, and it is the whole square. This 2 can be written like that. Now it will be same as that above. That will be A naught e raised to the power minus lambda t has a value of 1 by 3. 1 by 3 square. So A is equals to A naught by 9. The amplitude will become 1 by 9th. 1 by 9th means option number B. Next question. Do you want me to solve this question which is on your screen? Say yes or no very quickly. If you were able to solve this question, then I will leave it. Say something. Bhupesh, Logesh, Mohina, Priyadarshini, Ritu, do you want me to solve this question? There is another question. Which question out of these three you want me to solve? Out of these three, which question you want me to solve? Because we have very less time. Quick. I think this will be good. Okay, you want me to solve that question? Okay, I will solve that. First, see this. This is the question of optics and very important question. That was CBSE question that was written on the electrostatics part. The question says, final image, where will be the final image? So final image पूछ रहे हैं ये हमसे. For spherical surface or for refraction at spherical surface, there is a formula, there is a relation. What is the relation? Mu refraction divided by image distance minus mu of incidence medium divided by object distance is equals to mu of refraction minus mu of incidence divided by R. This is the relation that is going to be used here whenever we talk about refraction at a spherical surface. I think everyone knows that. If you don't know this relation, you might have studied it in terms of like this. You might have studied it like that. Mu2 by V minus mu1 by U is equals to mu2 minus mu1 by R. I think everyone should have studied that relation. But the actual form that you should remember is this one. Now it is very simple to put the values here. Refraction medium, rays are coming. If I can draw, this is, rays are coming like this. So this is the incidence medium and they will refract in this medium. So this is the refraction medium. Clear? So refraction medium has a refractive index of 1, that is 1 by image distance, let's suppose V, minus incidence medium is 3 by 2. Object distance is what? Object distance. This is a virtual object. Object distance is this one. And you can see the object distance is this one. And this distance is nothing but 30 into 30 is equals to mu of refraction, that is 1, minus mu of incidence, that is 3 by 2, divided by R. R is given as 20 centimeter. Now we can solve it. 1 by V minus, it will cancel 10, 1 by 20 is equals to, it will be minus 1 by 40. So 1 by V is equals to 1 by 20 plus 1 by 40. Sorry, minus 1 by 40. Now you can solve it. LCM will be 1 by V is equals to LCM will be 40. That is 1 by 40. So V is equals to 40 centimeter. Which option is correct? Option number A is correct. Now the question that you were asking is this one. Okay, let's solve it. Two identical metal balls with charge plus 2q and minus q. Okay, this is 2q and this is minus q. They are separated by a distance, some distance. Let's suppose the distance between them is r. So the force between them will be Ke. Product of charges, that is 2q square divided by r square. Let it be question number 1. Now what are they saying? These two charges are joined by a conducting wire, which is then removed. Now listen to me, the concept. The concept thing. What is the concept? Whenever two charges or two conductors are connected, the charge identical, I'm talking about identical conductors, whenever they are connected by a conducting wire, the charge equally divides between them. The charge equally divides between them. This is the thing for the identical conductors. So now what is the thing? This is a conductor, this is a conductor. They are connected by a conducting wire. This one. So when they are connected, the charge will be equally shared. Then how this charge you can distribute among these two conductors is the net charge after the connection. This has a charge 2q plus, this has a minus q charge. So total charge of this combination is q. Total charge of this combination is what? Q plus 2q and minus q. So net charge is q. And you want to share it equally. So if you share it equally, it will become q by 2 and q by 2. Clear. So final charge on these two conductors are plus q by 2 and plus q by 2. So what will be the force? Let's suppose this force is F dash is equals to K. Product of charges is what? Q square by 4 divided by separation is R square. Clear? This is equation number 2. Now, from equation 1, we can get the value of Ke Q square by R square. Ke Q square by R square. You can divide these equations, you will get the answer definitely, that's for sure. But I am doing what I like. Ke Q square by R square will have a value of F by 2. So I will put the values F dash is equals to F by 2 and 4 is already there. That is F by 8. This is our answer. You can solve which method you want, but the thing is F by 8, which is option number B. Is it clear? Okay, now it's time to end the session. Okay, there are a lot of questions remaining. Okay, let's end the session. Bye, everyone.